So me and Melanie and Sophie Mercy, some of you know, who was at the Norway meeting, have been working on this for a couple of years. It's taken a long time to publish, but it's about looking at how many taxonomists we need, what are the demands on taxonomy, and how we address the balance between the two. So taxonomists are a broad range of people, to say the very least. They both provide a service to biologists like yourselves, but also think of themselves as scientists and do hypothesis-driven science. They do all sorts of things. They identify things. They do things like phylogenetic analysis and look at evolution. They teach people how to identify things. They make collections, etc., etc. But they often complain. And particularly the ecologists, the entomologists. They keep saying there aren't enough of them because they compare the number of them with the number of insects, and they say we have way too many insects for us to be able to describe all of these insects. And yes, that is true, but not all organisms are equal. I'm afraid to say not all insects are that important. And what are the drivers of why we need taxonomists, and who is going to pay for all insects to be described, for example? So our workflow, we've tried to make this as automated as possible, looks at taxonomic publishing and identifies taxonomists from people who publish taxonomic papers. So even if you've published one paper that we consider taxonomic, we would get you from our workflow. So we identify taxonomic journals from various places, and we use the open bibliography, Open Alex, to pull out information on papers. And we can take the authors from there. We can use various means like using ORCID IDs to disambiguate those authors. And we can use abstracts from those papers to figure out what people were working on, which organisms. And then we can start putting that all together to get interesting information. We have a nice saturation curve, so we know we're actually picking up quite a lot of authors, and we think we get most of them. The disambiguation works reasonably well, but we think our results are quite valid. And then we can do phylogenies, for instance, and you're probably most interested in the bottom one, where you can see that's a phylogeny of all animals, and the intensity of the color is how many taxonomists there are. And as you can see, out of all animals, the arthropods, and particularly insects, are well covered by taxonomists. Not enough, apparently, but they are there. The big gaps in taxonomy, it seems, are the soft, squishy things that live underwater. Mollusks, platyhelminths, nematoda, annelida. So marine, squishy things. People are not really interested in. Things with a backbone, there are plenty of taxonomists around. Things with an exoskeleton, plenty of taxonomists around. And looking at the others, yes, higher plants, vascular plants, and in the fungi, it's mostly the basidiomycetes that are of interest to people. So we want to compare that to drivers of taxonomy, and so we looked at 9 different policy relevant things and made phylogenies of those. So these phylogenies, the other ones were separated by the kingdom. These are all kingdoms, all in each phylogeny. And if you look at the bottom right, you'll be interested in pollinators, unsurprisingly, or insects. If you look at the crop wild relatives, unsurprisingly, they're all vascular plants. If you look at the birds directly, they're all birds. But you can look at invasive species where there is some more variety, but you can still see a bias towards vascular plants, towards things with a backbone, and towards insects. You can look at things like the Habitat Directive, the Marine Framework Directive, and Red List, and you get a bit more variety, but it still comes down to vascular plants, chordates, and insects. And the poor old fungi, squishy things, get ignored a lot by policies as well. You can look at the correlations here. I won't go into a great deal of detail, but I'm going to point to here, but down the bottom of that top left graph, you can see the number of species is a big correlate with the number of taxonomists. But you can explain a lot of the variation by adding in the policies into the models. So policies and the number of species are both important drivers of how many taxonomists we have. The big question is, what drives what? Do taxonomists drive the policy, or do policy drive the taxonomists? And I would say a bit of both. And I think the big message for you is that with greater engagement between the people who make the decisions and yourselves as biologists, you get a much tighter link between the policies, or you can drive policies that get created by those decision makers. And also, they come back to you and also want to drive you in a certain direction. That's why they give out funding, things like that. So it is a two-way street, but often it feels in taxonomy like people are talking to each other with megaphones, whereas it would be much better if we had a fora where it was much easier to talk about the issues such as pollinator decline in a much more direct and open way. We can do other things with this, looking at the distribution of taxonomists. So although there are fewer taxonomists in the East than the North, if you look per capita, it changes quite a lot, and that disappears to some extent. But of course, it shouldn't be per capita, it should be per species. So that's a bit of a question. And I'll finish there.